Right, question 15. This one is on logs and exponentials and model and using them. So, in a simple model, the value v of a car depends on its age t in years. That means is v and t are going to be part of the formula to figure these things out. The following information is available for car A. Its value when new is £2,000 and after 1 year it's £16,000. Use an exponential model to form for car A a possible equation linking v and t. Right, when it says use an exponential model, there is a general format for that. It means that you are going to have your overall thing that you're working out equals some number. Sorry, the overall thing you're working out, which is v, not a, equals a times e to the kt. So what this means is we need to figure out the value of a, we need to figure out the value of k. T is the number of years, which is what you asked about in the question, and v is the value of the car. So what we can do here is that we can use these two sentences to figure out these things. So I know that when the car is new, that means that time will equal 0. Its value is 20 grand. So if I put value as 20,000 equals a times t equals 0, e to the k times 0. Remember that e to the k times 0 just gives you e to the 0. E to the 0 is 1. So a times 1 equals 20,000. That means that a must be 20,000. Whenever you do these, basically the initial value is always the number that goes there. So now we've got that v is 20,000 e to the kt. Now what I can do is use the second one, because this basically means that when t is 1, v is 16,000. So plug them in. So I get 16,000 equals 20,000 e to the k times 1, which is just k, isn't it? So I'll divide those. That can give me 16,000 divided by 20,000, which is 0.8, equals e to the k. Now if you remember from the previous questions, we're going to take logs of both sides here and bring the k down in front. So we're going to get log of 0.8 equals k log of e. Remember, log of e is just 1. So that tells us that k is log of 0.8. I can plug that into the calculator. If I do log of 0.8, it gives me that k must be minus 0.223. So my equation is v equals 20,000 e to the minus 0.223 t. Right, part B. The value of car A is monitored over the 10-year period. T is going to equal 10 somewhere. Its value after 10 years is £2,000. Evaluate the reliability of your model in light of this information. So what this means is, after 10 years, it actually is worth 2 grand. And when we are looking at the reliability of our model, and we use our model to predict values, it basically means see what value your model is going to give you after 10 years, and then compare it to this one. So we let t equal 10 in our model. So we're going to get that v equals 20,000 times e to the minus 0.223 times 10, and just shove that in your calculator. So 20,000 times e to the minus 0.223 times 10, and that gives me 2,150, which is close to 2,000, and therefore I'd say reliable. Right, part C. Following information is available for car B. It has the same value when new as car A. Its value depreciates more slowly than that of car A. Explain how you would adapt the equation found in A to this equation so that it could be used to find the value of car B. So effectively what we want to do here is, it would mean that as the values change over time, it would mean that because card B depreciates more slowly, it would mean that card B would be worth more as time progresses. Not more than it was, but card B would be worth more than card A as time progresses onwards. So there's one easy way that we could do that, is we could just add a constant to it. That would be an easy way of doing it. We could just say, well, for every add £1,000 on each year. Another way of doing it, that's not a particularly reliable way of doing it, to be honest with you, but it is one way of saying, well, this thing will just always have a little bit more money on top of it as it goes on, because we're just going to add £1,000 on each time. Another way of doing it is, if we think about this, V equals 20,000 times e to the minus 0.223t. That value there, that coefficient of t, that could increase. It can't go above 1 because, it can't go above 0, because the second it does, it means that the value increases. But we could make it bigger without it going over 0. So we could increase the value of k, but still keep it negative. So what that would mean is, say we increase that to, I don't know, minus 0.18t or something like that, it would mean that the thing would still start on the same value. It would still depreciate, but it just wouldn't depreciate as much. Okay, so those are your two options there. You can either add a constant, or you can increase the value of k, but you couldn't have it going over 0, because the second it does, it means that the value of your car would increase over time instead of depreciate over time.